Here are your objectives for section 1.2. Number 1, solve linear equations in one variable. Number 2, solve linear equations containing fractions. Number 3, solve rational equations with variables in the denominator. Number 4, recognize identities, conditional equations, and inconsistent equations. And number 5, solve applied problems using mathematical models. Now this is going to be an objective in quite a few of our sections. It's going to say something like this, and it basically means we're going to do word problems over the stuff from above. Okay, so there's not, anytime something like this shows up, we're not going to be doing a whole lot of more examples because it's just word problems about all these things up here. Okay, so first of all, can you solve a linear equation in one variable? Well, I sure hope so, because you've been doing that, I think, since 7th grade. Maybe 8th grade, but it's been a while. Okay, 2x plus 5 equals 10. Can you solve that equation? Subtract 5 from both sides. 2x equals 5. Divide both sides by 2. X equals 5/2 or 2.5. Yeah? So something interesting, I don't know if you know this or not, just for the record, is subtracting 5 the only first step that you can do? You can actually divide by 2 first. Did you know that? If you have 2x plus 5 equals 10, if you divide everything by 2 first, you're allowed to do that. You get x plus 5/2 equals 5. And then when you subtract 5/2 from both sides, 5 minus 5/2 is 5/2, because that's 10/2, right? 10/2 minus 5/2 is 5/2. We got the same answer. We didn't do the same first step. You're typically taught to add or subtract first, because that sometimes minimizes fractions that you have to deal with. It didn't in this case. Well, I guess you only had to deal with the fraction at the end. Here we had to deal with fractions throughout. I just didn't know if you guys knew that or not. Sometimes people will say the only thing you could do first is subtract 5, and that's just not true. Okay? All right, second thing on our objectives is to solve linear equations containing fractions. Well, we kind of did that already. Mostly, I think what they're talking about is solving linear equations containing fractions, and when the fractions are either the multiplier on the front or they look like this. 2x plus 5 over 3 equals 9 over 6. Okay, if that's what the problem looks like, you can either get a common denominator here, even though you don't really want to do that. You want to actually get rid of the denominators, and you can do that by multiplying both sides by something that will simplify both denominators. So in this case, we would choose a 6. 6 divided by 6 is 1, so that's just gone. On this side, 6 divided by 3 is 2, so this whole side needs to be multiplied by a 2. When we do that, we get 4x plus 10 equals 9, and then it's just a matter of solving the problem. So 4x equals negative 1, and dividing both sides by 4 gives us x equals negative 1/4 as our solution. Okay, now we can make sure, we could plug this back in to make sure that that is correct, but it is. So hopefully you're okay with that. Okay. Our next objective is solving rational equations with variables in the denominator. Okay, when we did that in high school Algebra 2, we usually called it rational equations. Okay, typically if you're talking about equations that have fractions, those are just basically linear equations unless the variables are in the denominator, and then those are rational equations. Okay, those kind of equations look more like this. 4 over x equals 5 over 2x plus 3. Okay. Same thing here. We could choose to get a common denominator and just deal with the numerators at that point. But a lot of times people find it easier to eliminate the denominators. In order to eliminate the denominators, though, you have to know what would be the common denominator if you were trying to get a common denominator. Hopefully you see that that would be a 2x, because for this to be a 2x, I only need to multiply it by a 2. This one's already a 2x. This one doesn't have anything, so 2x is fine. So if I multiply each of these terms by 2x, everything, so I'm multiplying every term, the x's simplify right here, the 2's and the x's simplify here, and there's nothing to simplify there, so it's just straight multiplication. In the first fraction, what I have left is 2 times 4, which is 8. In the second fraction, the 2's and the x's both simplify, so I just have a 5. And here I have 3 times 2x, which would be 6x. When I subtract 5 from both sides, it gives me 3 equals 6x. Solving for x, I just divide both sides by 6, so x is 1/2. Does that make sense? Okay. Another example of that, because there's lots of different ways that you can have rational functions, rational equations. Oops, that's supposed to be a minus. Pretend that's a minus. So I have 4 over x plus 5 plus 2 over x minus 5 equals 32 over x squared minus 25. Well, hopefully you realize and remember that x squared minus 25 is the difference of squares and can be factored as x plus 5 and x minus 5. When you're trying to figure out what the common denominator would be, look at what they all share. Okay? Now, they don't all happen to share anything, but these two share an x plus 5 and these two share an x minus 5. So hopefully you would see, or at least can understand why I might choose x plus 5 times x minus 5 as my common denominator. So to get them all be the same, I would just have to multiply this equation by x minus 5, this equation by x plus 5, and then that's all the same, right? Now, another way to think about it is this. If I'm trying to get rid of both of these two, I want to multiply the numerators by both x plus 5 and x minus 5. Okay? So what I wrote first was if I was trying to get a common denominator. But remember, we're not trying to get a common denominator, we're trying to get rid of the common denominator, or get rid of the denominator in general. So now what I'm doing is I'm just multiplying every term by what would have been the common denominator, which is x plus 5, x minus 5. Here the x minus 5 simplify. Here plus 5. Here the x minus 5 simplify. And here both of them simplify. Okay, all of us simplify to 1. So in the first fraction, all that we have left is 4 times x minus 5. 4 from the original problem and the x minus 5 from what I had left here. Second fraction, I have a 2 from the first original part of the problem and an x plus 5, which is what I had left when I simplified everything. And then here, everything simplified, so all I have left is the 32. So in order to solve this, I can just distribute here and here and get 4x minus 20 plus 2x plus 10 equals 32. I just combine my like terms. 4x and 2x is 6x. Negative 20 and positive 10 is a negative 10 equals 32. When I add 10 to both sides to solve for x, I get 6x equals 42. Dividing by 6 gives me x equals 7. When I plug that back in there, it works. I can do that for you if you want me to, but typically, a lot of you guys are learning to check your work using the calculator, so it's kind of repetitive for me to go through the conversation of what's happening. Does that make sense? Okay? How are you feeling about rational functions? Okay with that? Okay. So our third objective was the rational functions, rational equations. Okay? And then fourth is recognizing identities, conditional equations, and inconsistent equations. I for sure want to talk about that just to make sure that that's something that you feel confident with. Okay? An identity is something that you know to be true. Okay? An identity would be something like this. X plus 3 equals x plus 2 plus 1. Well, if I simplify the right-hand side of this equation, do you guys know 2 plus 1? It's 3, right? Wouldn't that just be x plus 3 equals x plus 3? Doesn't x plus 3 equal x plus 3 because it's exactly the same thing? then that's an identity. Okay? Now, a conditional statement or a conditional equation, really, would be something like this. If I solved this, 2x plus 3 equals 17, if I subtract 3 from both sides, this is kind of like what we talked about at the beginning, right? Solving linear equations. If I subtract 3 from both sides and then divide both sides by 2, I get something like x equals 7. Well, x equals 7 is conditional on this part of the equation being true, right? That's a conditional equation. And the last vocabulary kind of thing that they want us to know right now is an inconsistent equation. An inconsistent equation would be something like this. X equals x plus 7. Guys, does x equal x plus 7? Well, if I tried to solve it, I would solve it by subtracting x from both sides, right? That would give me 0 equals 7. Does 0 equal 7? Does 0 ever equal 7? Ever. No, this is not true. This is a conditional equation is when you solve an equation and get an answer that's conditional on what the original equation was. An inconsistent equation is just an equation that's just not true. It's simply not true. Okay? You get an answer that it just doesn't work. All right? And then, like I told you earlier, solving applied problems, those are going to be word problems based on the structure of what was given to us in the first couple of objectives. All right? You have any questions about that? Okay.